We are here today, all in this room, and it's for a reason. And it is to solve a problem, and we promise you it's going to be fun. So our session is called Hello Quality, Building CI to Run Providers Package System Tests. I'm Freddy, and I'm a software engineer at Google in the Cloud Composer team.
Hey everyone, my name is Rahul, and I work at Astronomer.
I don't need a microphone. My name is Dennis. I work at AWS.
All right, so here's the outline. We're gonna first start talking about the problem that we will be solving in this session. Then we're gonna talk about the solution. We're gonna propose and talk about the solution we have. Then we're going to go into a technical deep dive, more on that later. Next steps, and finally, and Q&A for your questions. So what is the problem we're trying to solve? Again, why are we together in this room? When I first joined Google, which was around 1 year, 6 months, and 5 days ago, one of the first tasks I was assigned to is to do some modifications to an operator in the Google Providers package. All right, so I did the modifications. I ran some unit tests. I did some manual tests, which require some infrastructure to set up. But honestly, I was very scared. Like, I just joined Google. It was a perfect opportunity for me to create a global outage, to be famous, be on TV. Okay, I ran the unit tests, but I guess we all here know how reliable the mocks could be. I did manual testing, and we also know how reliable I can be. Luckily for us in Airflow, there is the concept of system tests. So for those who don't know, how are system tests represented in Apache Airflow? System tests are represented as actual DAGs, which have actual operators that run. Like, they test a real end-to-end scenario. This is an example, but let's zoom in a little bit. This is an example of a system test that tests the Google Cloud Run operators. So as you can see, this is a DAG. It's testing the create job run operator, the Cloud Run execute job operator, list operator. So first we're creating some jobs, we're doing some assertions, we are running the jobs, other assertions. So here we are testing the actual flow. Well, what are the pain points of running those system tests? All right, so I wanted to run the system test for the first time in my life. So I read around 10 pages of documentation. Then I asked my colleague who was the actual documentation. So, okay, I set up a Google Cloud project and infrastructure on GCP because we were testing some operators in Google Providers packages. Okay, so I ran the system test. The first time it failed because of configuration errors. I ran another time. The second time it fails also because of configuration error. But you know, they say that the third time's a charm, and they are right. The third time I run it, it worked. So as you can see here, we have this is one of the pain points. Like, you need to set up an infrastructure, which could be quite cumbersome. And you need to sometimes have good knowledge of what the system test is testing to know, for example, if you need extra configuration, extra infrastructure and everything. Not the easiest thing to do, honestly. And second, luckily for me, I work at Google. I have access to Google Cloud resources. I can run them for free, relatively for me. But let's say you are a person who is very happy to fix a bug or contribute some operator to providers package. So here you have two choices. The first choice is to pay money for the infrastructure. And the second choice is to use the money for something, I don't know, maybe buying a vacuum cleaner. All right, so now I hope the problem that we have is clear. I'm going to give the floor to Rahul from Astronomer to talk about the solution we proposed.
Thank you, Freddy, for outlining the problem. So now, as Freddy has already mentioned the problem statement, now let's dive into solution. So as per me, the solution is, first of all, addressing all the pain points and then automating it. And one of the pain point what Freddy mentioned was understanding of system test. And I completely agree to him that, let's say I know the architecture of that system test and I know that how it works, but maybe one of my colleague might not know, right? And this could be a problem at the time of testing or at the time of provider release. It may take time and we might miss running the test as well, right? Including that we do have a pain of infrastructure setup as well. So imagine if there would have been a way in which we these all system tests are executed by itself, right? And the results are stored somewhere, which can be accessible to everyone, right? And anyone can go and monitor the health of their providers, right? Wouldn't that be great? And I'm pretty sure that it would be very helpful in Airflow provider release process specifically. I'm not sure how many of you are already aware, but we do have this implementation for at least some of the providers. And the solution is implementing and maintaining system test dashboards. So these system test dashboards reside already in our ecosystem of Airflow, right? And currently we have 4 system test dashboards which are already there. One is for Amazon provider created by the Amazon team, then Google provider created by Google team, and the LLM providers created by the Astronomer team. And also recently, Teradata team has also created their Teradata provider. So the unique thing about these providers are the way they are implemented. So every dashboard is solving the same goal. However, the implementation of all these dashboards is unique. Now, I would be talking about the benefits of these dashboards, right? So first benefit is that it ensures reliability and stability. Now, being from a QA background, and I know each one of you here, right, we all want a quality product to our end users. And these system test dashboards specifically, right, they help us ensure the reliability and stability. Anyone can go to this dashboard, monitor the health, right, and let's say as a creator, right, as a provider maintainer, I've created a new PR, right, and the thing which worries me a lot is that whether my changes has introduced any regression or not. So I can go to these dashboards and verify the health. The other thing is that, let's say if I had added a new system test in my dashboard to increase my coverage, I'm talking about the code coverage, right? These tests automatically get added to these dashboard as per this implementation. So this is how helpful this can be. Now the second thing is, this provide a great help during Airflow provider release process. And I have experienced it by myself because I'm usually test all the provider releases. So as most of you know, we have bi-weekly releases of Airflow providers. And sometimes it happens, right, most of the team members of specific provider they don't get time, or they are not able to test it properly and not able to vote even. And this, what it costs is, it costs that if there are any bugs in those provider, those are shipped, and then there is another cycle which we need to create in case of any issues. So if we have these tests automated, everything can be checked and it can be verified. And it can provide confidence to the team members as well and to the release manager specifically. The third thing is test infrastructure setup. So creating the infrastructure for all these providers in Airflow itself can be very costly. And if each one of our team, right, if the provider, maintainers, and creator, if they take this ownership, create these tests, and own the infrastructure, it can not only help in terms of cost, but also can help in maintaining these infrastructure, because as these are owned by specific teams, we can have different infrastructure which is easy to maintain. So looking at all these 3 benefits, I encourage all the provider, creator, and maintainers to, first of all, put emphasis on creating system tests, because these can replicate the real world scenarios, right? And it helps us ensure the quality of our provider release. And as I said that, the providers which we have created, the system test provider which we have created, all are created as per the needs which is best suited for the teams. So that is how we can create. Now, today we would be talking about how we have created these 3 of these system test dashboard. We would be talking about Google, LLM, and AWS. The Teradata team, unfortunately, was not able to join us today. However, this is how their dashboard looks like. I would encourage everyone, this is their dashboard link, to go to this dashboard link and see how the dashboard is. And obviously, you can connect the team to see how they have implemented it. Now we would be talking about how Freddy and his team at Google Composer has implemented the system test dashboards. So over to Freddy.
All right, so thank you, Rahul, for explaining the solution and for showing the Teradata dashboard. So now I'm going to show the dashboard that we built at Google. This is how it looks like. Basically, on the first column, we have the DAG ID, or let's say the name of the system test. Like we said previously that each system test is represented as a DAG. So here you have the name of the DAG. And in the last column, we have the run statuses, those little green cute dots. Each dot is a run status. If it fails, if it's red. If it doesn't fail, it's green. And we also have like the system test dashboard. Every CI run it's run on the head version of Airflow with the head providers of Google Providers package. And this is run like once every 6 hours. But we have another internal version of this dashboard, which is used to test Google Providers packages RC candidates before they are released. All right. So once we decided that we want to create our dashboard, we were all called in inside the room. So we went inside the meeting room. We sat on a round table. No, actually, it was a rectangular table. And we wanted to plan, okay, the first question we were trying to solve is, okay, how would we run the system tests manually? First things first, and priorities first, we created a fictional character. Let's call him Bob. All right, so how would Bob run the system test? Bob would first need to turn on his computer. Now, let's say that Bob is a classic and doesn't have a high-end laptop where you don't have to turn it on and off and everything. And then Bob would have to install, like, git clone the Airflow repository and install Airflow. And let's say that Bob now wants to test also a specific version of the provider's package. So Bob would have to clone also the specific version of the provider's package and do some file manipulation to paste this provider's package folder in the Airflow repository that he cloned before. And after, okay, we clone Airflow from sources. Bob has to copy the system test that he wants to run inside the DAGs folder. And after it, we have to start Airflow and run those DAGs. And after the DAGs are run, we want to save the results somewhere. All right? So unfortunately for us, Bob was too expensive, so we decided not to hire him. So, okay, we want now to automate those steps. So instead of having Bob turning on a computer, we decided, okay, why don't we create a virtual machine, a compute virtual machine on Google Cloud. And then we SSH inside the machine. We clone the Airflow repository. We install Airflow. We install all the dependencies. Then we copy the Google Providers package system test DAGs inside the DAGs folder. We launch Airflow and run the system tests, and then we save the results in a database. And for our case, we used BigQuery. Why BigQuery? It's just very simple to use. For the sake of space, I omitted a last step, which is generating our dashboard, this one here. So we have a last step, which takes the last 10 runs from the database, and it generates this cute dashboard. So, all right, so now we have those steps, and before deciding not to hire Bob, we had Bob to go and run, like have his hands to turn on the computer or create the compute machine and everything, but now we don't have Bob anymore. And so we needed to find a state-of-the-art orchestration tool to run those steps. So we stood out from our rectangular table and we decided to do a circle, a very cute, warm, cuddly circle. And we decided, okay, like our goal was to find which tool to use to orchestrate this workflow. So idea after idea, thought after thought. There was an intern in our room who was shadowing our meeting. He was not in our cute circle, warm circle. And he was like for 30 minutes saying, hey, 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 hey. And finally, someone from our team decided to give him an eye and said, what? The intern said, those steps here, they look like a DAG. So we decided to use Apache Airflow to run Airflow, to test Airflow. Technically, we use Cloud Composer, which is managed Airflow, to run those steps, to replace Bob, by the way. This is what Bob was supposed to replace. I didn't know how big the screen would be, so I took my precautions. Let's zoom in a bit. So we have a one-to-man mapping between the DAG that orchestrate like creating the machine, sitting inside of it, and destroying Airflow and everything. I'm not gonna talk here, it's self-explanatory. I'm gonna leave this slide for a few seconds. And that's the second part. All right, I hope this was clear. And now I'm going to give the floor again to Rahul from Astronomer to explain how he and his team built the LLM dashboards.
Thank you, Freddy. Last year, our team at Astronomer were building LLM providers. And I think Ankit was one of the contributors sitting here itself. So while we were building these providers, right, the major thing what we thought is that we need to, obviously everyone does that how they can ensure that the quality of the providers is up to the mark, right? So not only for now, but also ensuring that how, if in case we put any other change, right, that does not regress. So we were just looking around the ways that how we can put something in place which can ensure that there are no regression in future as well. And at that time, while exploring, we noticed that there was already an implementation in Airflow ecosystem, right? And that was Amazon system test, right? So we connected with the AWS team, we saw how they implemented it, and also explored different ways. And after exploring, we thought we can utilize our own environment as well for that. And now I will talk about how we at Astronomer implemented our dashboard. So our dashboard contains a couple of components. One is GitHub triggers, Astronomer deployment. Astronomer deployment is a managed Airflow service, and obviously Airflow repo. We are using the Airflow main repo. So this is how the system test dashboard looks like. So just to add, right, most of the dashboard you will see, they will look almost similar like. So the intent is to display the results, the counts, and how we can check the dashboards are live and active. So this dashboard also contains 4 columns. First is DAG. In the DAG column, you see all these examples. These are nothing but system tests which resides in the Airflow repo. We have success and fail column, which obviously just show that how many system tests succeeded or failed. And then on the right, we have the last 7 run. We are storing the last 7 results. And also, when you hover on the icon, you see the run ID. So that is important because with the help of that, we can go to our deployment and see if there are any issues, which is very helpful. This last updated is very important because it shows when was the last time the dashboard was active. And it gives a lot of confidence to anyone who is looking into this. So this is the link for our dashboard. You guys can go to that and see the dashboard. Now let's talk about how we implement it. It would describe the test execution workflow. So as I mentioned that we are using GitHub Action Job. So this is a scheduled job which we have in our workflow, which does clone the Airflow repo, the main branch. We wanted to be on main branch because we wanted to ensure that we are taking the latest code on the main and wanted to catch bugs early. After that, we are using Breeze to create the wheel files for these providers. And we use Breeze because we wanted to be as close as to the Airflow ecosystem. Afterwards, we copy all the system tests from the main repo, create through all the folders for all these LLM providers, and copy the system test. After copying, we build an image with these system tests and the wheel files, which we deploy in our Astro deployment. So after deploying, we wait for the deployment to come up, and then we trigger the system tests. We are using Airflow API here to trigger all our tests and wait for completion. After the tests are completed, we update the dashboard with the recent results. So we have talked about that, what is the motivation behind creating this dashboard. We have discussed how we are the workflow of the test, and we are triggering the system test, but we did not discuss that how we are orchestrating and binding all these system tests. So we are also using Airflow to test Airflow here, as Freddy used in there. So we are using an orchestrator DAG, which is binding all these system tests together using the trigger DAG operator. And afterwards, we get the results and publish it to our internal Astronomer Slack channel. That is important to us because we wanted to be notified as soon as we see any failure and work on that accordingly. So this is a snippet of how the DAX looks like. So we have a couple of tasks here, if you see, and these tasks represent the system test stack. So on the top, we see the VB8 tasks, which are in sequence, and the below we have for Cohere, OpenAI, and Pinecone. So all of these other one run parallel to each other because we wanted to save on time. So we have some other tasks as well, like get Airflow executor version. These are important because these provide metadata to our report. And then the get report task, which essentially is using the Slack operator. It format the report and publish the results onto the Slack. So this is how our internal report looks like. It is very basic. It provides what we need. It has some metadata about run and also the success and failure count. We have the link to the deployment, which can be accessible in case of any issues. So we have not discussed how we are updating the dashboard. Now to update the dashboard, we are again using the trigger. We are using the GitHub action job, which is a scheduled job. We can trigger it as well. After triggering that, it retrieves the result from the Astronomer deployment using Airflow API as well, and stores the results of the last 7 run in a JSON file. As soon as we see that there are some difference into the JSON file from the previous version, we know that there are some recent runs, and accordingly we update that into GitHub, and then deploy the GitHub Pages workflow, which updates the dashboard for us. After the dashboard is updated, we again notify onto our Slack channel. This is important because we wanted to ensure that even if the tests are running and we don't have any failure, but our dashboard is updating, because the end goal is to ensure that the dashboard is active and visible to everyone. So this is how we updated and created our dashboard at Astronomer. Now I would hand over to Dennis, who would be talking about how he and his team at AWS implemented the Amazon-provided dashboard.
Hi, I'm Dennis with AWS. So I've been kind of hiding off in the corner, and there's a bit of a reason for that. We were actually the first ones to implement the dashboard, but we went about it a completely different route. You've seen Astronomer and Google. They both use Airflow to run Airflow to test Airflow. They're running them all as a DAG. Essentially, a system test is what I knew before Airflow. I knew it as an integration test. We're using PyTest to run it for ours. So here's an example of what our dashboard looks like. I want you to keep in mind, so far you've seen 3 examples, and the end product pretty much looks the same for everybody. Keep that in mind. We're going to come back to that. The implementation on all 3 has been completely different. As you'll see on mine, I'm going to point out a lot of differences on how we run ours versus how they run theirs. Part of the advantage, obviously, of the system tests and being run by providers is that these require accounts. For example, to run these tests, you need an AWS account. We don't want to pass that cost on to the community. We're taking that cost on as the provider. And we'll be coming back to that as well later. So in effect, we're using all internal AWS tools to run our tests. We're using Code Pipeline is going to pull down the most recent main branch on Airflow, and we do that roughly every hour. And it puts out the metrics to CloudWatch, and on a failure, we get notified, which I also noticed. Astronomer gets notified every run. We only get notified on failures, so I'm going to say we win that one. Who wants to get paged every hour? So here's a bit of a drill down on what our dashboard includes and what it looks like. We have a new feature in the top right corner there, where there's a tab for the different executors, which we're working on and I believe just launched. So we've added the ECS executor last week. We'll be adding tabs for all the different executors as well, which will look very similar. We're going to have every test run under each executor, so you can check it based on what you want to run it on your environment. And then like everyone else, we've got the test name, how many runs, how many failures, how long it lasted. That's all pretty standard. So what we're using to run our test is it's event-based here in the center. Really wish there was a red dot on this guy. In the center there, it's an event-based, so every hour or so it triggers a code build, which pulls down the local or the main branch of Airflow. And we also have it triggered so you can trigger it on a specific SHA. So you can run it, for example, against release candidate or a specific breaking change to find out where things broke. That's going to trigger code build, pull that down, and pushes it into Code Pipeline, which runs each test. The Code Pipeline is essentially going through and for each test in the folder, use PyTest to run it. Each test gets its own complete container, its own fresh environment, all the dependencies, all that get installed fresh for every single test. So there's no chance of one test causing side effects that fail another test on you. Everything's in a clean environment. And then down in the bottom right here, you can see each test emits a number of metrics. There's whether or not it was invoked with the timestamp, whether it succeeded or failed, and the duration that it took. So that means we can also get alerts. For example, if it hasn't been invoked within 24 hours, we get a notification, something's wrong. Doesn't happen very often, but for example, sometimes on long weekends, holiday weekends, there aren't any pushes into the Airflow main. So then we don't get triggered because there's nothing to change. And then we get paged because it's been a slow weekend, which seems kind of weird. In case you were too bored, here's a page. For the actual generating the dashboard, we've got again, it's a time-based event triggering a Lambda. Lambda is just running a Python script, which builds out the static website. The website gets uploaded to S3, and then that goes to github.io, which is the public interface. So our dashboard is actually hosted here on github.io. And that's pulling all the data from the CloudWatch metrics that I mentioned earlier. Like I said, we get notified on failures instead of every single run. So after the PyTest runs and it logs the metrics, it can cut us a ticket, it sends a Slack message. It seems like we all use Slack, which is kind of interesting. And then that's embedding, link to the logs, all that kind of stuff. The dashboards themselves all look pretty much the same, but we all took different routes. So one of the things that I like to discuss here is what's next. What's next is hopefully some of you will join us. We were looking for other providers to generate their own dashboards as well. These are useful for users. They're essentially unit tests or unit tests for operators or integration tests for operators. These are actually calling the actual operators against actual services. So that's the use case, and that's why these are providing value to the users. We don't want to specify, we don't want to dictate how you create these, how you run them. As you can see, we all took very different approaches. What we do want to discuss is how you output the data. So right now, we all took very different routes and basically landed on the same result. So what we want to do as our next step is to standardize that output into some sort of a machine-readable code. We're all, I believe, all outputting JSON in some format, but we never standardize on a schema. So what we want to do is standardize an output schema for JSON. And what that can do, that can actually open a lot of doors. So this is a proposal that we've got forward, which will hopefully, well, there haven't been any objections yet, so hopefully it'll be standardized. It's basically broken down into two portions. You got the test suite at the top. That's your provider information. So we can see here, there's the provider, how many tests were run, how many errors, how many failures, how many were skipped. The timestamp of the run is kind of important. The duration of the run, we're going to leave optional. And then properties. You see properties is on here 3 times. So basically properties is going to be a free-form field. So anything that the provider wants to include in there that's not part of the standard. For example, up here in the test suite, you might include the SHA code for the commit that was used in the test. So when you start seeing failures, you can trace that back. Or there's some other examples in the next coming slides. And the second portion is a list of cases. Basically, we've got the provider and then all the tests that they're running. The test cases, again, the only required fields are going to be the name and the result. Everything else is pretty much optional. So what this might look like as a bare minimum would be this right here. So here, the provider, AWS, ran 1 test, no errors. We can see I can't math because I failed 1 and skipped 1, but somehow only ran 1. But math, hey, that's why I learned to program, so computers can do that for me. The timestamp, and then the list of details. So we say here, we ran 1 file, and it was a success. So for all the providers who adopt this standard, this is what we'd expect for the absolute minimum for your output for the JSON. And here's an example of a slightly more detailed successful run. So you can see here at the top line, we added a pretty name. So that would be like the display name. How long it ran, we're going to standardize. They'll all be in milliseconds, just so they're all standard. And then threw in some examples here of what might be included in properties. So we can see here a link to the source code for the system test. Seems like a useful thing. And then maybe since these are essentially integration test for operators. Let's list all the operators that are tested in this test. One thing that'd be kind of neat is if that does get more adopted as a user, you would be able to ingest all this because it's all just JSON. And you can say, my DAGs use this operator from Google, this operator from AWS, this operator. You just merge them all, collect them all. And you only have to actually look at which tests you care about, right? Instead of having to look at this whole dashboard and visually pick out which ones matter to you. And then go to Google's dashboard and see which ones they have. And then go to Astronomers and see which ones they have. So once this is standardized, you'll actually be able to just aggregate it and just look at what you need. Some more examples for a skipped one. You can include an optional message in there, including, and in this case, for the properties, I included in the properties, you might include a link to the docs page about why that test was skipped, for example. For failures, again, I like the source code to linking to the test that failed, but you can also include which tasks exactly failed. So even if you're testing, for example, the AWS batch, there's a good number of tasks within that test, so just saying the test failed isn't so useful. So this can at least let you know which API call on that service is failing, right? I want to thank you guys for coming out and joining me for this talk.